Hello, everyone. Today we are going to talk about partial fractions and partial fraction decomposition. Let me start with an example which explains what are we going to mostly deal. Imagine that somebody has two fractions, 1 over x plus 1 plus 1 over x minus 1. And somebody decides to bring it to common denominator. Well, common denominator here is going to be what? X plus 1, x minus 1, right? And what is missing here on the first fraction is x minus 1. So I put x minus 1 here. And the second fraction is missing x plus 1. I'm going to see that in numerator, I can add x's and get 2x. And I can add numbers and get 0. And denominator is going to be x plus 1, x minus 1. So two fractions are combined into one fraction. What are we going to learn in this section is how to go back. If somebody gives you one fraction, you can represent it as two fractions. For this class, we're probably not going to use it a lot, but in your future calculus classes, in integrals, when you start calculus 5b, it's going to be one of the kind of methods we use to integrate fractions, decompose it into simpler fractions. You see why these fractions are simpler? Well, if you compare this fraction, the last fraction, it has x plus 1, x minus 1. So it has kind of two factors in the denominator. Each of these two fractions has only one factor. How are we kind of solving actually, or planning to kind of go back here? Well, we are going to use so-called method of undetermined coefficients. How the method is going to work. I'm going to take this fraction, and looking at denominator, I kind of understand that the fractions which were combined, let's imagine that I don't know them, are kind of number a divided over x plus 1 and some number b divided over x minus 1. Because if I combine these two fractions, eventually I'm going to get something like fraction with denominator x plus 1, x minus 1, and something in numerator. So a and b here are going to be these undetermined coefficients. A and b undetermined coefficients. Well, my goal is to actually figure out what was a and b. And if I find them, I will be able to represent this fraction in two fractions. How do I find them? Well, first, I'm going to actually kind of do the process of bringing to common denominator. So common denominator is, again, x plus 1, x minus 1. And the numerator, we have a, x minus 1, plus b, x plus 1. I'm going to open parentheses in numerator. So I have ax minus a plus bx plus b. And here in denominator, x plus 1, x minus 1. I'm actually going to combine terms with x, a plus b, x plus b minus a. Why I'm doing this? Okay, so I'm trying to bring my numerator to the shape of a polynomial arranged by powers of x. Now, what I'm going to do, guys, I'm going to compare the numerator of my given fraction and the numerator of my fraction with undetermined coefficients. And I see that if I want them to be equal, be same actually, my coefficient is supposed to match. So for example, my coefficient of x here is equal to 2, and here is equal a plus b. And my coefficient of x to the power of 0, which is just 1, right? Here it's 0. There is no coefficient, no free term, right? And here is b minus a. And we have to solve these two equations together. That's exactly what we learned when we learned the systems of linear equations, right? How do we solve it? Well, here I'm just going to add actually first and second equation. So I have 2 equals minus a and a are going to cancel, and I'm going to have 2 equals 2b, from where b equals 1, right? And then if I plug in b equals 1, over here, I'm going to see 1 minus something equals 0. Okay, then a equals 1, 2. And yes, I do get the same numbers here. That's my a and that's my b, which I knew already. But if you don't know them, that's a way to find them back. And that's how we do this partial decomposition. Okay, now I'm going to consider another example, and just like example where we don't know original fractions. Here we kind of found the original fractions, so now we can write down that instead of a is 1 and instead of b is 1, right? But what if we don't know original fractions? Will we be able to solve the problem back? Let's consider example number 2. X over x squared plus 3x minus 4. Yeah, this example is slightly different from what we had before because it's not factored. So the step number 1 is going to be factor denominator. What are the factors? Usually they're easy to find. The sum is 3 and the product is 4. Probably they are x plus 4 and x minus 1. How about this? So the product is minus 4 and the sum is plus 3. Perfect. Now we are going to represent it as a sum of two fractions, a x plus 4 plus b x minus 1. And after that, we're going to start the process of bringing to common denominator and setting up the powers of x. Okay, so a x plus 1 minus 1, sorry, x minus 1 plus b x plus 4 divided over x plus 4 x minus 1. Guys, because we are planning to compare only numerators, I'm not going to keep more denominators. We already kind of used denominators. They served us. So I'm going to just use numerators. So I'm supposed to have x equals, here if I simplify it, it's ax minus a plus bx plus 4b, right? If I multiply b by 4, I'm going to get 4b. And I'm going to kind of bring the terms with same power of x together, a plus b, x over here, and here minus a plus 4b. Now I'm comparing powers of x. So here we don't have a coefficient, means that the coefficient is equal to 1. And we compared the x, the first power x to the first power. So this expression equals to 1, right? X to the 0 power has no coefficient. So I'm going to compare this expression to kind of 0 here. And write down that 0 equals minus a plus 4b. And solve it like I was doing before. Usually, guys, the results are not going to be very nice, but it's not going to stop us from solving anything. Here, for example, I'm going to add these two equations, get 1 here, right? 1 plus 0. A is going to disappear and 4b and b are going to make 5b, from where b equals 1 over 5. Now, if I plug it into this equation, I'm going to find that a plus 1 over 5 equals 1, from where a probably equals to 4 over 5, right? 4 over 5 plus 1 over 5 equals to 1. So what does it mean, guys? I'm going to write down my final results. That fraction x squared plus 3x minus 4 is going to be decomposed into 4 over 3 over x plus 4 plus 1 over 5. It was 5 actually. Why did I say 3? That's 5. But I wrote 5 and somehow I said 4 over 3. 4 over 5. 1 over 5 x minus 1. So I did decomposition. Sometimes people, sorry, I keep erasing what I'm writing down. Sometimes people who are doing these calculations are going to put this in denominator and put it in front of the fraction. You don't need to do this. We're going to be fine if you don't do it. Okay, so guys, this decomposition is called case 1. I'm going to kind of call it case 1. So case 1 happens when you have a polynomial in numerator, something like, I don't know, p of x. And in denominator, you have something like x minus a, x minus b, x minus c, linear factors. Linear factors. And they all are different, non-repeated. Then you decompose it into a, x minus little a plus b, x minus little b plus c, x minus little c. And if you have more of them, just more of the fractions. Now, case 2. Case 2 is going to happen when you have some of the factors repeated, linear repeated factors. What I mean by repeated, let me consider example. 2x plus 3 divided over x plus 1 squared x minus 2. I'm going to label this one is repeated twice. 2 times. How it's going to affect our solution? Well, not much actually. For repeated factor, we are going to have two fractions, a over x plus 1 and b over x plus 1 squared. For non-repeated, which is x minus 2, we're going to just have c over x minus 2. And of course, when you have more letters, means that you are going to have more variables in your equations. But again, it's not super difficult to bring it to common denominator. I'm going to actually work only with numerator and write down that my numerator is going to be on this side 2x plus 3 and on this side a. By what I'll need to multiply a? By x plus 1. X plus 1 is missing here, right? Because there are two of them. And x minus 2. X plus 1, x minus 2. And b, what is missing? Well, the square is here already, so I don't need to multiply by this, but x minus 2 is missing. And for c, I'm missing x plus 1 square, the whole thing. Okay, guys, I'm going to show you a different method from solving a system of equations. Maybe you like it and it's going to make your life a little bit easier. The method is going to look like this. Let's look, what are zeros here for each of these parentheses? I see minus 1 and I see 2. So what I'm going to do, guys, I'm going to use these zeros. So I'm going to start x equals minus 1, and I'm going to plug in minus 1 everywhere. Minus 1 here, for example, is going to give me minus 2, right? Minus 2 by minus 1, minus 2 plus 3. That's just going to be a number. Minus 1 over here is going to give me 0. Minus 1 over here is going to give me b by minus 3, right? Minus 1, minus 2. And minus 1 over here is going to give me 0 again. Well, guys, what is here? We have 3 minus 2, which is 1, right? And on this side, we have minus 3b, from where we can easily calculate that b is negative 1 over 3. Now I'm going to repeat the process with x equals 2, because that's another 0. 2 by 2 is going to be 4, 4 plus 3 on this side, and 2 here and here are going to give me zeros. Only 2 is going to, which is not gonna give me 0, is over here, right? Let's see, 2 plus 1 is 3, 3 squared is 9. And 4 plus 3 is what? 7. And on this side, I have 9c, from where c is 7 over 9. Only one little question. I'll still need a b, but I already used both, minus 1 and 2. What should I do? Well, guys, for b, because you don't have any extra roots over here, we can use any number. Because you already know c and a, you can just substitute them here. So I'm going to write down that's like 2x plus 3 equals, my a is what? No, I don't know a actually. I'm going to write down a, x plus 1, x minus 2. I know my b, right? B is minus 1 over 3, x minus 2. And c is 7 over 9, x plus 1 squared. I can plug in any x here, and it's still supposed to work, right? I'm going to plug in x equals 0. X equals 0. So here I'm going to have 3. X equals 0 here is going to give me 1 minus 2. So it's minus 2a minus 1 over 3. 0 is going to give me minus 2 and plus 7 over 9. And 0 is going to give me just 1 square. Well, now I'm just going to see equation is just having one variable a, and you can easily find it. So I have 3 minus 2a, and I'll need to combine these numbers. So it's plus 2 over 3, 2 and 3 plus, right? Plus 7 over 9. Okay, so I'm going to bring all numbers on the right side and all variables on the right. So I'm moving this one here and this one here. So it's 2a equals 2 over 3 plus 7 over 9 minus 3. And I'm going to calculate actually the numbers, okay? It's not very good to put 2 equal signs, but to make it a little bit faster. So the common denominator of all these expressions is 9, right? So I multiply this by 3, it's 6 plus 7. If I multiply 3 by 9, it's minus 27. And over here, 9. So I'm going to get the final expression is 27 minus 20 plus 6 is minus 14 over 9. Yeah, the number does not look very good, but that's okay. So I'm going to just get my a, because I have 2a here, I'm going to divide by 2. Minus 14 over 9 divided by 2 is going to give me minus 7 over 9, right? We remember that division by 2 is multiplication by 1 over 2. Well, I got my fractions. Now I can write down my decomposition. Sorry, I moved it too far, and I already don't remember the numbers. Let me kind of just cross. So my a is what? Again, minus 7 over 9. Minus 7 over 9. My b was, my b minus 1 over 3. And my c was, let me go back, c was 7 over 9. Guys, normally we don't cross a, b, and c. We just rewrite everything but with numbers. Otherwise, that's it. We decompose the fraction, okay? And that's how we are going to decompose it if you have a repeated factor, but it's linear factor. Last case is going to be case 3. There are actually 4 cases, but we are going to stop at case 3. Because you see that the calculations are more and more complicated. Irreducible quadratic factor. What is a reducible quadratic factor, guys? Well, I'm going to consider two expressions, x squared minus 4 and x squared plus 4. You know that you can represent x squared minus 4 as x minus 2 and x plus 2 using the formula. But you cannot do it over here because actually this one has zeros plus minus 2, and that's why you can represent it. And this one has zeros, x plus minus 2i. So actually you can represent it as x minus 2i and x plus 2i. Usually, guys, we don't like to deal with I. So we are going to call equations which we cannot factor into linear factors irreducible quadratic. Quadratic because of this. Irreducible because, well, you can reduce it, but with complex numbers. In real numbers, you cannot represent it like this, okay? So this is irreducible quadratic. Well, how are we going to change our solution if it has irreducible quadratic factor in it? Okay, example. Consider example 2x squared minus x plus 4 divided over x cubed plus 4x. If I factor denominator, I'm going to get 2x squared minus x plus 4. And x outside of these two terms is going to give me x squared plus 4. So I have x here, and this is irreducible quadratic. Well, guys, how it's going to work? For x, it's like x minus 0, and I'm just going to have a over x. For this one, we are going to have two letters, bx plus c. So the numerator of irreducible quadratic factor is going to be a linear factor, bx plus c. And that's only the difference we're going to have. Now, from this point, solution is supposed to be kind of exactly same as you already had before. So we bring it to common denominator. So that's what I'm going to do. I'm going to write down 2x squared minus x plus 4 on this side. And on this side, common denominator is x squared plus 4 missing here and x missing here, right? So a x squared plus 4 plus bx plus c multiplied by x. Here, guys, I'm going to open parentheses. It's going to be faster than to do anything else. So it's ax squared plus 4a plus bx squared plus cx. Simplifying my right side, that's a square, is going to give me a plus b, this term and this term together, x squared plus cx plus 4a. Actually, guys, this one, though it looks harder, it's going to be easier. I'm going to start comparison. For example, 4 and 4a, there are three terms here and here, right? From where a equals what? 1. By what you will need to multiply 4 to get 4? 1. Cx and minus x are the first power of x. So actually we see that c equals minus 1. And the only unknown factor we have is b, right? And b equals a plus b equals 2. So I'm going to write down 2 equals a plus b. We already know that a is 1, so it's 2 equals 1 plus b, which is going to say, okay, b is equal to 1. Why? Well, 1 plus 1 equals 2. So my fraction is going to look this way. Where is my a? A is 1 over x plus 1 my x plus, where is my c? C is negative 1, minus 1 x squared plus 4. Usually, guys, people don't write down this 1 over here, so just write down x. And that's kind of decomposed expression. Okay, so what is the difference? Major difference here is that we are going to have this special fraction. My pen stopped working, special fraction. So over here on the top, you are going to have bx plus c or cx plus d or whatever. If it's quadratic here, it's going to be linear here. The last case, I'm not going to consider examples, but I'm going to give you the idea, like what is the case. That's going to be case 4. Case 4, we have irreducible repeated factor. Sorry. Let me write down repeated first. I'm going to give you an idea, but usually it gets so many letters. So it's going to take forever to solve. Well, I'm going to give you x plus 1 here and x squared plus 4 squared. So the factor is irreducible, and the factor is repeated. Okay, so what are we going to have if we have a reducible repeated factor? Well, for non-irreducible repeated, we are just going to have a standard a over x plus 1. But for this one, we are going to have bx plus d, like it was just irreducible. And then ex plus f over x squared plus 4, like it's repeated. So it's kind of irreducible. Because of this, we are going to have bx plus d. And that's repeated. Because of this, we are going to have the second fraction. And you see, it's already 5 letters. Very long solution to do, actually. Well, I suggest you to do at home at least like 3-4 problems of finding these letters. If you can do all, of course.